To add to that, I met Superman, but specifically Christopher Reeve's Superman, and I quickly became fixated on that iconic scene where he flies so fast that he reverses time in order to save Lois Lane. And that was it. That was my dream. I knew exactly what I wanted to do when I grew up. And quite simply, I wanted to fly. And so I set out on my new mission with my head held high and a can-do attitude. I did what any reasonable child would do. I went outside and I started trying to teach myself how to fly, because unfortunately, none of the adults around me seemed particularly willing to teach me. But after a few weeks and a couple bumps, reality landed hard. I needed to accept the fact that I was not the last son of Krypton, and so my dream of flight was grounded for a while. And after that, life just went on. I grew up and I went to school, and I finally embarked on a very different kind of flight, to fly at UP, towards my computer engineering degree. And I'm sure some of the guys here can relate. I pulled my first ever all-nighter, building a line-following car, and somehow I enjoyed it. I dove headfirst into projects that encoded messages, modulated and demodulated signals, and I even built a room mapping robot from what most people would call scraps. But it was during some of these more challenging times, what I would personally call my dark days, where I stumbled across BBD. They're a pretty great software engineering company, and they were gracious enough to offer me a bursary, which I think I very reluctantly accepted after a minute or so of deep reflection and deliberation. And I'm proud to let you all know that since then, I've graduated and I've joined BBD as a software engineer. Thank you. So since joining, I really haven't looked back until I came across videos of people flying, and that took me right back to my childhood dream. But they weren't really flying like Superman. They were flying FPV drones. But just like that, that old spark of mine was reignited. You see, I was also already looking for a hands-on way to get back in to playing around with hardware. I just missed it, and I wanted to tinker. And so I dove right in. And in a way, that childhood dream of mine of flying came true. Hi, I'm David, and today I want to share with you how I finally managed to reach my childhood dream of flying. Once again, it's not quite a Superman level of flight, but it's a really close second. Now, before we dive into how a drone works, or even what it's made of, we need to agree on one simple question. What exactly is an FPV drone? And to answer that, we need to break it down into two smaller questions. What exactly do I mean by a drone? And furthermore, what do I mean by FPV? To answer the first question, a drone is a quadcopter, which is a special kind of a multirotor. To break that down even further, a multirotor is just a fancy way of saying a flying machine with more than one motor. And a quadcopter is just a multirotor with, as you guessed it, 4 motors. So from here on out, whenever I mention drone, just picture a 4-motored flying machine, or even simpler, a quadcopter. And then onto FPV. The short answer is simply first-person view. But in the context of drones, we've got 2 main ways to fly. You've got line of sight and FPV. To start off, line of sight is where you control your aircraft by looking at it directly from where you're standing on the ground. But with drones, especially small ones like mine, it's really difficult to tell which way it's facing. And that then makes it very difficult to control it and fly it precisely. But that's where FPV shines. Because with FPV, you get a view as if you were sitting on the drone yourself. And that just makes it a lot easier to pilot it accurately, and it also just opens up a whole new world of immersive flying. So you just put those together. You have a quadcopter with a camera that sends you, the pilot, a live video feed of what your drone sees, and you've got yourself an FPV drone. So Now that we're all on the same page as to what an FPV drone is, let's just see how a drone gets to move around. In my opinion, it's one of the coolest parts of learning how to fly. Unfortunately for some of you, it does get a bit technical, but I have turned it into plain English as best I can. That being said, even if it doesn't all click for you right now, you're still more than welcome to go out into the real world and try to fly. I just think that understanding how this works and how your drone moves makes this whole experience of flight all the more rewarding. So let's get into it. Now, drones or quadcopters have 4 inputs. You've got throttle, pitch, roll, and yaw. We'll start off with throttle. It's the most essential one, and it's the control that gets the drone off the ground and into the air. Now, this is pretty simple. So when your motors spin, they spin propellers, and those propellers push air downwards. And thanks to Newton's third law, that downwards force creates an equal and opposite upward force called lift. Now, when your lift is greater than the weight of your drone rises. If not, you either hover, stay grounded, or you're going down. And if you're going down, I hope you can catch yourself. So, throttle's pretty simple. More throttle, more power, more lift, airtime. So, now that you're airborne, the next step is just going forward. And to do this, you need to use something called pitch. For the nerds, it's rotation around the y-axis, or simply your drone leaning forwards or backwards. So, if you want your drone to move forwards, you need to pitch forwards or pitch down, and to do that, your drone is going to slow down the front motors and speed up the back ones. That's going to make your drone lean forward, and now part of that lift force that was holding you up is redirected to push your drone forward, and then your drone moves forward. And to fly backwards, it's the same thing, you just swap which motors are faster and which ones are slower. And to fly sideways, we'll need to use roll. It's rotation around the x-axis, or simply your drone leaning from side to side. It comes into play pretty similarly to how pitch does. But instead of changing the speed of the front or the back ones, you change the speed of the left or the right ones. So if you want your drone to roll to the right, you drop the speed of your right motors, increase the speed of your left ones, your drone leans to the right, and you move right. And to go the other way, once again, it's just the opposite. So at this point, you're in the air and you can fly in any direction. But one thing you need to keep in mind here is that whenever you pitch or roll, a part of your lift is redirected to push your drone in the direction in which you're pitching or rolling. And that means that you need to increase your throttle a little bit in order to maintain altitude. And that's a part of what's called throttle control or altitude control. And it's one of the most important skills to learn while you're learning how to fly. That being said, let's finally move on to the last control, yaw. It's what your drone uses to spin in place, and it's what you can use to change the direction in which your drone is facing. This does come into play in a bit more of a complicated way than pitch or roll, but in my opinion, it's one of the most elegant ones, purely because of how beautifully the physics comes into play here. So, remember that I said a drone or a quadcopter has 4 motors. 2 of those motors spin in a clockwise direction, and the other 2 spin in an anti-clockwise direction. And that's done intentionally. It stops your drone from spinning uncontrollably in either direction due to the reactive torque or the reactive rotational forces from your motors. So when all 4 of your motors spin at the same speed, those rotational forces just cancel one another out. But if you wanted your drone to spin in a certain direction, let's say clockwise, what you would do is you would drop the speed to the clockwise motors and increase the speed to the counterclockwise ones. That's going to then create an imbalance in reactive torque, and your drone spins clockwise. And to spin the other way, it's the same, just the opposite. And that's that. You've got throttle to go up, pitch and roll to fly in any direction, and you use yaw to look around. If you combine those 4, you've got full 3D control of your drone. So, thankfully, the physics lesson is behind us, so let's move on. Now, at this point, I knew that I wanted to fly an FPV drone, but I really didn't know much about them. So, like any curious nerd of the modern age, I hit the internet. And before I even found out what my drone would be made out of, I needed to decide, do I build a drone or do I buy one? So just buying a drone would have been the quick and easy way out. I'd be up in the air in no time, but I also knew that once I absolutely inevitably crashed my drone, which is just a part of the process, I wouldn't know how to fix it. But more importantly, I'd be missing out on a golden learning opportunity. You see, I didn't just want to fly. I wanted to tinker again with hardware and get to soldering just like I used to. And so I decided to kill two birds with one stone. I'd learn something new, and in the process, I'd get to flying, just like little me wanted to do all those years ago. But yet, another minor inconvenience came across me. I didn't just have drone parts lying around at home. And to add to that, I didn't even know what drone parts were. So once again, I hit the internet, YouTube, Reddit, just blog posts, and I finally came up with a list. Specifically, my FPV shopping list, and that just came down to a few items. So let's dive into those. First and foremost, it's the frame. It's the most visible part of your drone, and you can think of it as your drone's body. And just like your body, its job is to hold everything else together. Now, when choosing your frame, there's a few important things that you need to consider. The first of which is the frame size. This does sound a little bit weird because your frame size isn't actually defined by the frame itself, but rather the size of the propellers your frame can hold. So, if someone speaks about a 5-inch drone or 5-inch frame, they mean that the drone or frame is big enough to hold 5-inch propellers. And in general, 5-inch drones are really popular in freestyle FPV flying, which is what I wanted to do. So I made the decision of a 5-inch freestyle drone. And then we've got the shape. There's tons of different shapes out there, but in the context of freestyle drones, the two most popular ones are X and Dead Cat. To start off, X is creatively named that because it's shaped like an X. Dead Cat is pretty similar, with the exception that the front two arms are pulled slightly backwards, and that just keeps the propellers out of view of the camera. Both of these shapes perform really well, but X frames are known to be a little bit more stable at high speeds and during tricks. And because of that, for that extra stability, I chose an X frame. And then we've got the material. Now, as I mentioned, any drone that flies is absolutely bound to crash. So that means that your frame has got to be tough. And that's why almost all drone frames are made out of carbon fiber. I learned pretty quickly just how tough carbon fiber is, because after a couple crashes that I thought would leave me with drone confetti and broken dreams, I actually had a working drone, a big smile, and an unused roll of duct tape. So all things considered, that's my frame. It's the foundation of my drone, and it was my first big decision. I chose a 5-inch X frame from Foxia. Moving on, we've got the stack. It's a key part of any FPV drone, and it's made up of two main components: your flight controller, or FC, and your electronic speed controller, or ESC. To start off, the flight controller is the brain of the drone. It houses your main processor and a gyroscope, and together those two let your drone understand its movement and its orientation in 3D space. Now, when it comes to processors, the two main types you'll come across are F4 and F7. Both of these are widely used and loved in the hobby today. But F7 processors just have a bit more power and they support more peripherals than F4s. And because of that, many hobbyists, including myself, just choose an F7 processor when we're building our drones. Moving on, we've got the ESC. Now, if the flight controller is the brains, the ESC absolutely makes up the muscles. It's what tells your motors how fast to spin based on signals it receives from the flight controller. It's also what translates your inputs from throttle, pitch, roll, and yaw into actual motor speeds. And in addition to that, it also handles power regulation for the rest of your drone, making sure that nothing is going to blow up or catch fire mid-flight. And because of that, you need to make sure that ESC can safely handle the total current drawn by your entire drone. All of that considered, I chose a Mamba Mark IV. This has an F7 processor, and the ESC is rated for 65 amps of current. So, considering the brains and the drone, the stack absolutely makes up the heart and soul of your control system. If you choose wisely, you'll have a phenomenal flying machine. So, now we've got the motors. You can think of these as the legs of the drone. They would actually make your drone move by spinning the propellers. And when you're choosing your motors, you need to make sure that you consider your KV very carefully. For the nerds, KV is the motor's no-load speed per volt, or simply how fast your motor spins when there's no propeller attached. Now, in general, a higher KV just means faster motors, but that comes at the cost of less torque and worse efficiency. For 5-inch freestyle drones, you typically want your KV between 1700 and 2100. That'll give you a good balance between speed, control, and flight time. In my case, I got really lucky and I managed to get myself a second-hand set of T-Motor F60s. They're rated at 1950 kV, and that puts me right in the middle of that sweet spot for freestyle flying. And then we've got the battery. It's your drone's energy store. And once again, there's a few key things we need to consider here. First of which is a cell count. You can think of this as how powerful your energy store is. The more cells your battery has, the higher its voltage and the more power it can deliver to your motors. So a higher voltage means faster motors, but more cells also usually means a bigger and heavier battery, which means that your motors need to work harder. So you need to choose wisely here. In general, for freestyle drones, 6S or 6-cell batteries are the go-to standard nowadays. So that was my choice. And then we've got capacity. This just tells you how much energy your battery can store. And in general, a higher capacity means a longer flight time. But once again, a higher capacity also usually means a bigger and heavier battery. So it's another trade-off. Because if your battery is too heavy, your motors need to work harder and you burn through power quicker, which can then reduce your flight time and in some cases just defeat the point of even having a larger capacity. And finally, for the battery, it's a discharge rate, or simply your C rating. It just tells you how quickly your drone can pull power from your battery. So a higher C rating means flying faster, snappier tricks, and great punch-outs. So for snappy and responsive flight, you need a high C rating. However, once again, just like the other battery specs, a high C rating is probably going to give you a much bigger battery. So it's all about balancing your priorities. In my case, I usually fly with 6-cell batteries that either have a C rating of 150 or 160 and a capacity of either 1380 or 1850 milliamp hours. And that gives me up to 6 minutes of pretty fun freestyle flying. So your battery is super important. You choose wisely, you're going to have absolutely amazing flights. If you don't, good luck. And then we've got the video system. In my opinion, this is one of the most exciting parts of any FPV drone, and it's made up of 3 components. Your camera, which you can think of as a drone's eyes, video transmitter, which is what your drone uses to send you the video feed, and the video receiver or your goggles, which is what you use to receive and view your video feed. Now, when choosing your video system, you're going to have to make a choice. Do you go analog or digital? To start off, analog has been around for ages, and it's honestly what's gotten the hobby to where it is today. But it gives you pretty grainy and low resolution video. It kind of looks like watching a fuzzy TV channel or an old VHS tape. For the nerds here, it's called analog because that analog video signal is modulated using frequency modulation and is then transmitted to you in the 5.8 gigahertz band. And that means that as you fly further away from yourself and your signal drops, your video quality just gets gradually worse and worse. So you get more static, fuzz, buzz, but you can still fly for a while. However, the video quality is noticeably lower than that of digital. Speaking of digital, you can think of these as the spoiled younger brother of video systems. They give you crisp, HD quality video that just looks absolutely amazing inside the goggles. For the nerds, your video signal is compressed and converted into a digital stream. That stream is then transmitted to you using OFDM, which is similar to how Wi-Fi works. The trade-off here is simply that you get slightly higher latency, and when your signal drops, you don't get video degradation. You just get huge latency spikes and sometimes you can cut out. So the golden question, which one's better? And the answer, I don't know. They're both loved, and in some cases hated, by the whole FPV community. However, lately, hobbyists like myself have been gravitating more and more towards digital systems, and that's thanks to ongoing improvements in reducing latency and increasing image quality. So personally, I went with a digital setup, and I haven't looked back. I fly with a Caddx Vista on my drone, and that makes up the camera and the video transmitter. And that integrates pretty seamlessly with the DJI Goggles V2. And the best part of this is since my Caddx and the goggles are still well supported today, I'm pretty sure there's going to be upgrades, spare parts, and firmware updates for a good while going forward. But whether you choose analog or digital, your video system is simply what puts you in the pilot seat. And when it works right, it's one of the most amazing things to see in the hobby. And moving on, we've got our receiver and our transmitter. The receiver is kind of like the ears your drone uses to listen to you for your commands. And your transmitter is the voice you use to give those commands. So for those commands to be given and received, your transmitter and your receiver need to speak the same language. And in the world of FPV, that choice of language often boils down to ELRS or Crossfire. In general, both of these have great performance in terms of range and latency. But as an engineer, there's one difference that takes the cake. To start off, Crossfire is proprietary. It's developed and maintained by Team Black Sheep, and because of that, it's just known to be super reliable due to the premium hardware that's designed and developed for it. On the other hand, ELRS is an open source protocol. It's developed and maintained by an active community that consistently provides updates, support, and guides. So once again, the golden question, which one is better? I don't know. They're both loved by the FPV community at large. They both have their die-hard fans. But for me, after I saw that ELRS was an open source protocol, I went for that low-hanging fruit. I chose ELRS, so I have an ELRS receiver on my drone, and my transmitter can hold an external ELRS module that allows my transmitter and my receiver to be a part of the same conversation. In that same conversation, I'm good to go. And finally, I got a buzzer and a GPS. They're just some extras, and they give me a little extra peace of mind. The buzzer is just in case I ever lose my drone somewhere where it's hard to find. Real-world example is very long grass. And the GPS just lets me see roughly where my drone is, even when it's pretty far away from me. Gladly, I haven't needed it yet, but I'd rather have it and not need it than the other way around. And that's the shopping list. It's one and done. So, given that list, there's one thing that stood between me and my build drone, and that's a 90-second build montage. So I started off soldering my GPS. Needed the right power and signal connections, so there was very little room for error here. After that, I got to mounting the motors to the arms of the frame. Each motor needed 3 wires to be soldered down, and the order in which those wires were soldered didn't matter too much, because that only impacts the motor's direction, which I can change later on in software. After that, I got to component placement. I needed to think of where I wanted everything mounted. I needed to be able to securely mount everything, and I needed clean cable management, which just meant shoving wires somewhere where they'll never be seen again. Then it was time to mount. In some cases, I used machine screws, and when I couldn't use machine screws, I just used some strong double-sided tape and zip ties. I then got to assembling the smaller parts of my frame, and just like that, the build was just about done. And so I had a built drone, but did I actually put it together correctly? You see, a lot of components needed to get soldered down, And as a human, it's very easy to make a mistake and accidentally short-circuit something. So, to make sure that nothing was actually short-circuited and that nothing would blow up as soon as I plugged in the battery, I needed to do a smoke test. And that needed a smoke stopper, which as the name suggests, just stops your drone from smoking if something is wired incorrectly. Let's see how that went.
I think it's okay, bro. Yeah.
All music and no smoke. I'll count my wins for now. So at this point, my drone was fully built and it passed the smoke tests, but it didn't know what it was. And that's where something called Betaflight comes in. Betaflight is some software that lets me configure my flight controller. I can tell my drone what it's connected to, and I can also fine-tune how my drone behaves. Now, I can go on and on about Betaflight, but I think two of the most important things to consider here is your ports and your motors. This is the ports tab. Now, depending on where I connected each component during the build, I needed to assign it to the correct port here. One feature I really like is my drone's built-in Wi-Fi module. Sadly, there's no internet, but it lets me wirelessly connect to my drone through an app that I have on my phone. And that means that even when I'm out in the field without a laptop or a PC, I'm still able to connect to my drone and check or tweak settings if I need to. And then we've got the motors tab. Now, one of the most important things to do here is just to tell Betaflight what kind of aircraft you're flying, which in my case is an X-frame quadcopter. And then you also need to tell Betaflight in which direction your motors are spinning. An easy way I use to remember this is just your motors need to spin inwards to the frame. And if they don't, your drone is going to pitch, roll, and yaw in weird and wonderful ways if it can even get off the ground at all. So, with all of this considered, let's just take a second to step back and reflect. So, I have a fully built drone that passed the physical tests, and at this point, I've correctly configured it in Betaflight. So surely that's it, right? Surely it's time to fly. Yes. Let's see how my maiden flight went.
Okay.
Thank you. So that honestly, like the plan went off the rails pretty quick. But it was my first flight, so it had to be beginner's bad luck. So, maiden flight V2? Yeah, I should start like a garden maintenance business or something. But I could hold it in the air, which was better, but it's nothing like what I'd seen online. Surely, third time would be the charm. Drone 3, David 0. So as it turns out, not only am I not Superman, but I also just couldn't fly. And here's a few more videos I have as evidence to that. Now, in all of these crashes, the problems boil down to just a few repeat offenders. The first and most glaring is just my lack of throttle control. You see, quite often I'd start with too little throttle, and then I'd overcompensate and slam it up to 100. And my drone would shoot skyward like an over-caffeinated squirrel, like it was trying to escape the atmosphere, which would then lead me to panic and cut the throttle to 0, which really just didn't help. In addition to that, I was just unfamiliar with the controls. I'd roll instead of pitching, I'd yaw like I was swatting a fly, or I'd combine all three, and in the process, mow the lawn or prune a tree. Those mistakes made it very easy for me to lose orientation, which then meant that recovering was just impossible. At this point, my patience was wearing thin. My drone smelt like a lawnmower, and that just begged the question. Surely, there's a better way to learn how to fly without butchering my wallet and my drone. And the answer is yes. We've got something called flight simulators. Now, if you're thinking about getting into FPV, I'd absolutely recommend starting with one. I spent several hours in a sim, and while it's not quite the same as real flight, it's great to learn the fundamentals without risking your drone or countless sets of propellers. So I use a simulator called Liftoff. It's available on Steam, although there's really no shortage of other great options out there. If you want to give it a go, all you need is a transmitter and you can take to the skies. The sim also has a wide range of flight modes. Firstly, you've got free flight. It's super relaxed and you just cruise around a map at your own pace as you experiment with flying and tricks. And then you've got freestyle. The goal here is just to land as many tricks as you can within a minute. The more tricks, the higher your score. And what you're seeing behind me is race mode. It's pretty tough, and that's exactly what makes it addictive. You get multiple maps, each map has multiple tracks, and each track has its own difficulty. And once you think you've mastered a track, the real test is trying to push for that first place finish in a race, even if you're just racing bots. After all, can you really claim mastery if you can't even beat the competition? Now, for building muscle memory and just learning how drones handle and respond, sims are absolutely the best way to learn how to fly before you take to the skies for real. So, after I spent just over 24 hours in liftoff, I decided that it was time to give real flight one more try. And this time, the results were on a whole different level. Practicing in the simulator had taught me so much, going from precise throttle control to the ability to recover smoothly from mistakes, all the way to reading my altitude and my orientation as if they were second nature. But I think that the biggest shift of all was a mental one, because I finally had the confidence to go out and actually enjoy every flight, instead of just clinging onto the sticks in pure survival mode. And in all honesty, there are times when I surprised myself. And best of all, I got to live out little me's dream of truly flying, not just wobbling in the air, but actually going out and owning the flight. On this particular day, I was flying at an airstrip that's owned by the flight club I'm a part of. It's tucked away just behind the Ramsar Stadium, where we've got a wide stretch of runway surrounded by open space. And on Saturday afternoons, this place has its own kind of magic. Pilots roll in with gear bags and flight cases as they set up their planes, their helicopters, and in my case, my drone. The air hums with the sounds of spinning propellers and whooshes from high-speed passes. You'll hear focused silence from one group, laughter from another, and we'll all cheer when someone nails an amazing trick or great landing. Today, I was also flying with another drone pilot and a really good friend of mine called Bryce. He's a guy who first helped me get into the hobby, and in all honesty, he's a kind of pilot that just makes everything look effortless. Having him around just adds a tiny bit of comfort and, to me, a lot of competitive pressure. Going back to liftoff, I still use it today to keep learning, whether I just want to warm up, sharpen my control, or learn a new trick. I'll push my limits in the sim first, so that when I take it to the real skies, I'm already ahead on my curve. It's become a pretty constant loop for me. I practice, perfect, perform, and finally, I'll repeat. But for now, let's just hope that I can fly straight and hopefully stick the landing. So, now that you've seen what I see when I fly, let's see what this flying machine looks like in action. So, I've already strapped in the battery, so I'm just going to plug it in. And for those of you that can't hear at the back, I don't know if you know Levels by Avicii. That song was actually played by the motors. There's a buzzer, but it doesn't make that noise. Now, I'll just power up my transmitter, and I will wait for my transmitter and my receiver to bind to one another. I might just need to... Okay, there we go. That beep you heard is my ELRS transmission system saying that it's good to go. So I'm now going to tell my drone to get ready to fly by arming. First off, I'll drop my throttle back to 0. Now I'm armed, and I'll increase my throttle until I'm in the air. Now I'll pitch forward to fly towards you, and pitch back and roll towards myself. Keep in mind, I'm flying right now, and I'm not even wearing a cape. I'll bring it back down, and now that's a pretty simple flight. So while flying, there are some safety precautions you need to take because of the propellers. So some pretty good built-in safety features is just that your throttle needs to be set to 0, and you need to have an arm switch. If not, your drone is most likely just not going to arm. So now that you've seen my flying machine in action, let's step back and zoom out. Because what I think is really, really cool is how drone technology is being used outside of just flying as a hobby. Now, I'm sure you've all heard stories of companies like Amazon and Walmart delivering people's packages and groceries to their backyards. But it goes even further than that, because today, drones are being used in mining, agriculture, land surveying, military and surveillance, and even in emergency response. You've got some drones with specialized sensors to monitor crop and cattle health. You've got others that are fine-tuned for cinematic photography and infrastructure inspection. And that list, honestly, just goes on and on and on. What I'm trying to get at here is that this tech is growing. And as with all growing tech, it's only going to become a larger and larger part of everyday life for us all. So, if I've done a good job, and you're now thinking of building your own drone, or even just learning a little bit about the tech behind drones, here's a few sources I found along my way that I'd absolutely recommend. Firstly is Oscar Liang's blog post. It's an absolute goldmine of information, and it covers every corner of the FPV world. It goes from beginner tips and tricks to advanced configuration guides. He's really got it all. And of course, on YouTube, you've got Joshua Bardwell. He's the FPV jack of all trades. After all, in liftoff, Bardwell's yard has to exist for a very good reason. Rotorite is another great channel. They've got builds, flight tips, and gear reviews that just gives you a solid idea of what's good. And if you're just the type of guy or gal to enjoy some casual builds or freestyle flying, Truncate's FPV is the man for you. So, whether you came here for the tech, the takeoff, or just the talk, there really is a whole world of possibility out there for you in FPV. And who knows, this may have just been the lift you needed. Not to fly like Superman, but to fly like you. Thank you. Cool. While we take questions, I do have another flight video that we can just play in the background if you guys are interested. Cool. Cool. Any questions?
Testing. Dave, great talk. That was
Thanks, man.
really, really cool. I just want a quick question on your speed controller on your motors. Obviously, we did control systems and stuff. What kind of control system is used when you're doing your yaw and your roll and your pitch?
Yeah. So the control system actually runs on the flight controller, and it is a PID. So I can't remember what the PI and D values are at the moment, but yeah, I think I'm still actually on stock rates.
Okay,
but,
no pressure. I also don't know what they stand for, but I know. So thank you.
Great talk, by the way.
Thank you.
So I wanted to ask, what's the range of the drone in terms of distance, and what are the disadvantages of extending it, for example, if you wanted to?
Sure. Again, so I'm going to just answer that in reverse. So I'll start with the disadvantages and then I'll tell you the range. So disadvantages of extending your range is simply you're going to use more power. So you need to draw more power. So you need obviously a C rating that's going to allow you to pull that power. But then the range, so on mine, I've flown up to, I don't think I've flown more than 1 kilometer away from myself. And you can extend it. You just need to get an antenna that's going to be able to push that transmission power. But it's always the video that drops first. Cool. Alrighty. Cool. Thank you.